Imagine the smallest thing you can think of. Maybe a grain of sand, or a speck of dust, dancing in a sunbeam. Now imagine something a million times smaller than that. You are getting close to the world of the atom. Everything you see, everything you touch, and even you yourself, are all made of these tiny, tiny things called atoms. For a long time, we thought atoms were the smallest things possible. We thought they were like tiny, solid balls. But inside each one is a whole new universe of energy and power, a place of incredible force, a cosmic secret hidden in plain sight. Nuclear science is the story of our journey into the very heart of the atom. Think of an atom as a giant sports stadium. The nucleus would be like a tiny marble in the middle of the field. Almost all the weight of that stadium is packed into that little marble. It's held together by a force so strong it makes gravity look weak. This journey did not begin in a big, fancy laboratory. It started with curiosity, with scientists asking simple questions. What is light? What is everything made of? They were explorers, charting an invisible map of matter itself. Their quest led deeper into the fabric of reality. Marie Curie saw rocks that glowed with their own inner light, radioactivity. Einstein revealed a simple, powerful truth. E equals mc squared. Energy and mass are two sides of the same coin. Inside every atom, a vast reservoir of energy waited for a key. Hit a heavy nucleus with a neutron, and you can make it split. They called this process fission. The pieces weigh a little less than the original. And that missing mass becomes energy, just as Einstein predicted. The real power comes from a chain reaction. Like dominoes, each fall triggers more and more. In less than a second, trillions can split, unleashing a storm of energy. Once we learned how to start a chain reaction, the next question was, can we control it? Can we tame this incredible fire? That is the idea behind a nuclear power plant. Inside a reactor, the chain reaction is carefully controlled. Special control rods absorb extra neutrons, a gas pedal, and a brake for the atom. They release a constant, manageable stream of heat. That heat boils water into high-pressure steam, spins a turbine, and turns a generator to make electricity. Electricity travels to light our homes, charge our phones, and power schools and hospitals. A single small uranium pellet can equal a ton of coal. No need for mountains of fuel moving across a continent. And because nothing is burned, there is no CO2 from the plant stack. In a warming world, that is a huge advantage. Hundreds of reactors provide significant clean power around the world. Reliable, abundant electricity, 24 hours a day. It is like having a tiny, captive star on Earth. The power of the nucleus also heals our bodies. Nuclear medicine. Radioisotopes act like tiny spies we can send into the body. They gather where disease is active so doctors can see deep inside without surgery. Radiation therapy aims focused beams to destroy cancer cells while sparing healthy tissue. Many medical tools are sterilized with radiation to keep patients safe. Food irradiation kills bacteria like Salmonella and E. coli and reduces waste. Carbon dating uses C14 to reveal the ages of mummies, settlements, and ancient art. A tiny americium source helps many smoke detectors save lives. Nuclear batteries power probes far from the sun for decades. The same science helps us find water and minerals beneath our feet. It is a story with two sides, great hope and profound fear. It is about the choices we make when given the power of the stars. A journey that reveals as much about us as it does about the atom. The story of nuclear science has a dark side, a shadow that fell upon the world. The same chain reaction that promised energy held the potential for a weapon of unimaginable destruction. What if this immense energy were released all at once? This thought gave birth to the atomic bomb. In World War II, the Manhattan Project gathered thousands of brilliant minds in secrecy. They produced rare materials and devices to trigger a cataclysm in a fraction of a second. In 1945, Trinity exploded with light brighter than the sun. They had unlocked the power of the stars and created a monster. Weeks later, atomic bombs were dropped on Hiroshima and Nagasaki. Cities destroyed, hundreds of thousands killed. A new age of fear began. An arms race followed, amassing enough power to end civilization many times over. The darkest legacy of the atom. Even peaceful reactors carry risk if cooling fails. A meltdown is the most feared accident. Chernobyl, A flawed design and errors led to a catastrophic power surge and explosion. The core burned for days, releasing a radioactive cloud across Europe. A city became a ghost town overnight. Many responders paid with their health and lives. In 2011, an earthquake and tsunami overwhelmed Fukushima, causing 3 meltdowns. Not like Chernobyl an immediate toll, but a stark reminder of risk. These disasters forced stronger regulations and safer designs. Even with safe operation, what do we do with the leftover fuel? First, it cools in deep pools that block radiation and remove heat. Then, massive dry casks provide safe, temporary storage. The goal is deep geological disposal in stable rock for millennia. It is a scientific, engineering, social, and political challenge. No country yet runs a permanent deep repository. This long-term waste is a debt we pass to future generations. A long goodbye. Even with advanced technology, we must respect the power we wield. The lessons are written in history, and in our conscience. We cannot forget the shadow as we seek the light. We have journeyed into the heart of the atom, a secret that holds the power of a star. This starfire can light our world and heal our sick. It can reveal our past and carry explorers to distant worlds. But the same power forged weapons of unparalleled terror, and accidents have left a toxic legacy that lasts for ages. The atom is neither good nor evil. It is a mirror of who we are. We are designing safer reactors and pursuing fusion. More energy, far less waste. We are learning from Hiroshima, Chernobyl, and Fukushima. Our future depends on the choices we make. We have been handed the fire of the stars. We can use it to burn our world down, or to light the way. The universe gave us clues, our minds solved the puzzle, and now our hearts must choose. Let us choose to be good ancestors. Let us choose hope. Let us wield this cosmic power not with fear, but with the responsibility and wonder it deserves.